Carbohydrates are really important, really common molecules that we have inside living organisms and inside our cells. So they provide a major source of energy. So here we're going to do a really quick recap of the type of things that you would find if you're looking at structures, molecular structures of carbohydrates. So first of all, they are going to have lots of hydroxyl groups. And hydroxyl groups, recall, are the OH groups. In addition to that, we're going to have one carbonyl group. And then they will have also a short carbon backbone. And by short carbon backbone, we're talking about really 3 to 7 carbons long, and that's it. So these are relatively small molecules. And then these things that we've listed here, this is really what you would find in what we call a monosaccharide. So monosaccharides, which are the small ones, are going to have these particular characteristics. Now, once we put all of this together, what we're going to find is that our monosaccharide has a molecular formula that's some multiple of CH2O, meaning that we're going to have one water molecule for every single carbon that we have in that molecule. So if we go through and we draw a really simple one of these so that we can just look at it as an example, I'm going to draw this one 4 carbons long. One and only one of these is going to get a carbonyl group, and that could be one at the end of the molecule or it could be one in the middle. I'm going to put it on this very first one here. And then every single other carbon that we have inside is going to get a hydroxyl group. And that hydroxyl group could be pointing up, down, to the side. It really doesn't matter. So I'm just going to draw them in a variety of positions here for illustration purposes. And then all we need to do really is to fill in hydrogens here, and that would complete our structure. So I'm just going to add enough hydrogens around every single carbon to ensure that I have 4 lines coming off of my carbons. Every single one of them, because carbon always makes 4 covalent bonds, and that's based on its valence shell and the number of unpaired electrons that it has. So just again to review, lots of hydroxyl groups. We can see that here, here, and here. One carbonyl group. Here's my carbonyl group. And then we have a short carbon backbone, 3 to 7. We actually have 4 carbons in this particular example. If we come up with the molecular formula in this case, we just count up how many carbons we have. There are 4. Count up how many hydrogens. If you go through and count them, you'll find that we do have 8 of those. And then for the oxygens, there's 4 also. And that's the monosaccharide. They can get a little bit bigger than that, but the structure doesn't change too much. We can have ones that form rings though, and so the ones that form rings are a little bit different in their appearance, but you're still going to see lots of hydroxyl groups there. And if you come up with the molecular formula, it's still going to come up with some multiple of this right here. And again, remember that we're not looking at really large molecules. We're going to have up to 7 carbons when we're talking about the monosaccharides.